what is meant by electrical power? Power is in DC current. We have studied second chapter, current electricity chapter. We have studied power is equal to VI. So here also power is equal to VI, but we find the instantaneous power with that formula. EI is the EMF, I is the current. Instantaneous EMF is the instantaneous EMF, I is the instantaneous current, because every instant E and I are changing. So here we take, if it is an LCR circuit, all the elements are there. We are considering a circuit which contains L, inductor, resistor and capacitor. All the three elements are there, and we have got the current equation I equal to I0 sin omega t minus phi. In our derivation, we have seen voltage is leading, our current is lagging by a phase angle phi. Yesterday we have discussed that current is lagging in inductance dominated circuit. So dW by dt, power, work rate at which work is done by the electrical energy, the dW by dt, that is power, equal to EI. So E substituted E0 sin omega t, I is substituted as I0 sin omega t minus phi. Then E0 I0 sin omega t into this we expand sin A minus B. In that form we expand sin A minus, what is sin A minus B? Sin A cos B minus cos A sin B. That is the formula. So E0 I0 sin omega t into sin omega t, sin square omega t, then cos phi minus second one. You multiply this with the second term. So what we get E0 I0 sin omega t cos omega t sin phi. But we have added one, that means multiplied with 2 in the numerator and denominator. So there is a purpose for that, because 2 sin A cos A is sin 2A. In order to express in that manner, 2 sin A cos A is sin 2A. So you divide and multiply by 2. That is also done in that step. So next step is E0 sin square omega t cos phi minus E0 I0 by 2 into sin 2 omega t. We minimize it. Sin 2 omega t sin phi. Like that we have written. Next. You see, if this instantaneous power is assumed to remain constant for a small time dt, then the small amount of work done. But dW by dt is what we got. Therefore, what is dW? So dt comes here into dt, right side into dt. Therefore, total work done we can calculate. Because it is a AC, that's why we are first finding small work done, then finding total work done, because that values are varying. So for a small instant, we consider the current and voltage are constant in that manner. So dW first we find, then we take W. W equal to work done over a cycle, one cycle of AC. Time for that is 0 to capital T, time period of AC. Time for one rotation of the coil, like that. So one rotation, time for one rotation, that is the time period. So total work done over a cycle, one cycle of rotation, equal to integral 0 to T E0 I0 sin square omega t cos phi minus E0 I0 by 2 constant, that part is taken outside. Sin phi also is constant, phase lag, that is also constant, that is taken outside. Then integral 0 to T sin 2 omega t dt. Then next step, that is sin square omega t dt. See, there is a substitution for that, and this one also sin 2 omega t dt. See, integral 0 to t sin square omega t dt is t by 2. Steps I will show you. And integral, Integral sine 2 omega t dt equal to 0. If you study this one, you can avoid many steps. Understand? Steps I will show you how you got this. That I will show you. But see, if such derivation is asked, you can do that easy method. See, this is the steps I have written. Integral 0 to t sine square omega t dt. Integral 0 to t sine square omega t is written as 1 minus cos 2 omega t by 2 into dt. That is equal to half. This half is taken outside. Half into 1 into dt. First term. By 1 into dt dt. Then cos 2 omega t dt. Integral 0 to t cos 2 omega t dt. Then integral dt is t. Then apply the limit 0 to capital T. Minus integral cos 2 omega t is sin 2 omega t by 2 omega. This whole bracket raised to 0 to t. Then upper limit minus lower limit, capital T minus 0. Minus 1 by 2 omega into sin 2 omega capital T minus 0. Omega t is omega equal to 2 pi by t. Therefore, omega t equal to 2 pi. Omega into capital T is 2 pi. So, sine 2 into 2 pi. That means sine 4 pi. What is sine 4 pi? Sine 4 pi is 0. So, this term becomes 0. Then t by 2 only remains. T by 2. That's what I told. If you study this integral 0 to t sin square omega t dt is t by 2. If you study this, you can no need to write all these steps. No. So, biology students, especially maths students, may find it easy, but biology students may find it difficult to write all these steps. So, if you just study this step, integral 0 to t sin square omega t dt is t by 2, it will be easy for you. That's why I wrote it separately. Then another one, integral 0 to t sin 2 omega t dt. That is integral 0 to t sin 2 omega t dt is minus cos 2 omega t by 2 omega. That limit 0 to capital T. Minus 1 by 2 omega taken outside. Then cos 2 into omega into capital T comes. So omega into capital T is 2 pi. Minus cos 0. Then cos 4 pi, what is cos 4 pi? Cos 0, 2 pi, 4 pi, 6 pi, all are same value, 1. 1 minus cos 0 is 1, 1 minus 0. So that term also vanish because it becomes 0. So this is t by 2 and this is 0. So that is substituted. Directly you can substitute. Integral 0 to t sin square omega t dt, t by 2. T by 2 and my integral 0 to t sin 2 omega t dt 0 അത് 0 ആയി പോകും. അപ്പോൾ ഈ ടേം മൊത്തം പോകും. 0 അപ്പോൾ ഇവിടെ t by 2 വരും. അപ്പോൾ ഈ 0 ആയി 0 cos 5 into t by 2. അപ്പോൾ this is work. Understand? Therefore, average power in the inductive circuit over one complete cycle. Power എന്ന് പറഞ്ഞാൽ വർക്ക് ബൈ ടൈം ആണ്. അപ്പോൾ ബൈ ടൈം ചെയ്യണം. വർക്ക് ബൈ ടൈം. ലെഫ്റ്റ് സൈഡിൽ ബൈ ടൈം ചെയ്യുക, റൈറ്റ് സൈഡിൽ ബൈ ടൈം ചെയ്യുക. അപ്പോൾ ടി ക്യാൻസൽസ്. ഈ 0 ബൈ 2 വരും. ഈ 0 ടി ഗെറ്റ് ക്യാൻസൽ. ഈ 0 cos 5 by 2 വരും. അപ്പോൾ 2 is written root 2 into root 2. Root 2 into root 2. 2 is written. So, E 0 by root 2, I 0 by root 2 into cos 5. And what is E 0 by root 2? First derivation was that in AC. E 0 by root 2 is EV, virtual value. And I 0 by root 2 is IV. So, EV, IV, cos 5. That is the power in an AC circuit. Understand? So, very important derivation power in AC circuit. Here EV into IV is called virtual power. This is true power. True power. This is virtual power. Or it is also known as apparent power. And cos phi is called power factor. Power factor is deleted like that it says. So that means more questions will not come from power factor. Power factor and wattless current, that is remaining in this section. But that is deleted. So, but equation. Not all it is there. So cos phi, how will you find? True power by apparent power. That is cos phi. Understand? So this way you have to write and study the derivation. If any doubt in the steps, you can call me. Write and study. Final expression is very important. True power is equal to apparent power into cos phi. What is cos phi? Cos phi is power factor of the circuit. And steps. In special case, ശരിക്കും ഇത് ഡിഫറെൻറ്റ് കേസ് ആയിട്ട് പഠിക്കാം. മൂന്നെണ്ണത്തിന് ഇൻഡക്ടർ, കപ്പാസിറ്റർ, റെസിസ്റ്റർ, പിന്നെ എ സി അങ്ങനെ പഠിക്കുന്നതാണ് നല്ലത്. എ സി എല്ലാ എലിമെൻറ്റും കൂടെ ഉള്ളത് നമ്മളിപ്പോൾ കഴിഞ്ഞില്ലേ, ആ ഡെറിവേഷൻ പഠിച്ചു കഴിഞ്ഞിട്ട് സ്പെഷ്യൽ കേസ് കൊടുത്താൽ മതി. അപ്പോൾ ആൻസർ ആയില്ലേ. പിന്നെ പ്യുവർ റെസിസ്റ്റീവ് സർക്യൂട്ട്, പിന്നെ കറണ്ട് ആൻഡ് റെസിസ്റ്റൻസ് ദേ ആർ ഇൻ സെയിം ഫേസ് ഡിഫറൻസ് ഇസ് സീറോ. പ്യുവർ റെസിസ്റ്റർ, എ സി ത്രൂ എ റെസിസ്റ്റർ നമ്മൾ പഠിച്ചില്ലേ. കറണ്ട് ആൻഡ് വോൾട്ടേജ് ആർ ഇൻ സെയിം ഫേസ്. അപ്പോൾ ഫൈ ഈക്വൽ ടു 0 ആണ്. അപ്പോൾ കോസ് ഫൈ എന്താവും? പവർ ഫാക്ടർ 1 ആയിരിക്കും. അപ്പം പവർ എന്താവും? ആവറേജ് പവർ ഈക്വൽ ടു ഇ വി ഐ വി. അതാണ് കോസ് ഫൈ 1 ആയിപ്പോയി. അപ്പോൾ ആവറേജ് പവർ ഈക്വൽ ടു ഇ വി ഐ വി കിട്ടി. ഇനി ഇൻഡക്റ്റീവ് ഓർ കപ്പാസിറ്റീവ് സർക്യൂട്ട്, ഫൈ ഈക്വൽ ടു ഇൻഡക്റ്റീവ് സർക്യൂട്ടിൽ +π/2 ആണെങ്കിൽ കപ്പാസിറ്റീവ് സർക്യൂട്ടിൽ -π/2 ആണ്. പൈ അല്ല, π/2. പ്യുവർ ഇൻഡക്റ്റീവ് സർക്യൂട്ടിൽ +π/2 ആണ്, മറ്റേതിൽ -π/2 ആണ്. അപ്പോൾ കോസ് π/2 എന്താണ്? മൈനസ് ആയാലും പ്ലസ് ആയാലും ഇറ്റ് ഈസ് 0. സോ പവർ ബിക്കംസ് 0. In pure inductive or capacitive circuit, power is 0. The LCR circuit, cos phi equal to R by Z, cos phi. So the R by Z impedance of the LCR circuit is equal to root of R square plus XL minus XC whole square. So power factor formula ഏത് സർക്യൂട്ട് ആയാലും പവർ ഫാക്ടർ is R by Z. So you can write this also in that equation. Average power equal to EV/IV into R by Z. ഏത് സർക്യൂട്ട് ആയാലും. ഇപ്പോൾ റെസിസ്റ്റീവ് സർക്യൂട്ട് നോക്കിയാൽ Z R ആയിരിക്കും. R/R 1 ആയി. എന്തായി? EV/IV. അതാണ് ഇത്. അതെ, അങ്ങനെ. ഇനി അടുത്ത പോർഷൻ എന്ന് പറഞ്ഞത് LC ഓസിലേഷൻ ആണ്. LC ഓസിലേഷൻ നല്ല ഇൻട്രസ്റ്റിംഗ് ആയിട്ടുള്ളൊരു കാര്യമാണ്. LC ഓസിലേഷൻ LC oscillation എന്ന് പറഞ്ഞാൽ L is the inductor, C is the capacitor. And here we charge this capacitor with the battery and the key. First step is that we charge the capacitor with the battery and the key. Close this key. What happened? This plate of the capacitor become positive and this plate of the capacitor become negative. Now charging is done. It is fully charged. Okay. Then remove this plug and close this key. Remove the plug of key K1. Close this key. I'll ask question. What will happen? Where if the fully charged capacitor is kept there and it is connected to the inductor, what will happen? Tell. I will ask to Nandana, what will happen? Nandana? We have charged the capacitor fully and it is connected to the inductor. What will happen?
So charge will be transferred to the
inductor, flowing through the inductor. Correct. Okay. That charged capacitor, when it is connected to an inductor, we know that will pass through that charges will flow to the inductor. That means a current flows. Charges will flow through the inductor. So when charge flows through the inductor, what happens? When charge flows, correct. Ashley, correct. When charge flows through the inductor, magnetic flux linked with the inductor. So, and we know there is an opposition. Inductor always oppose the charge current. Phi is directly proportional to I. So, magnetic flux linked with that, if current charging is get delayed, this charging is get delayed due to the self-inductions of the coil. But anyway, that full charge will flow through the inductor, even though it will take some time. All the charge of the capacitor will flow to the inductor. So here the energy get transferred. In a capacitor, it is electrostatic energy. Electrostatic potential energy is there when charge is stored in the capacitor. And that electrostatic energy is changed into magnetic field energy in the inductor. Understand? So what happened? The charge flow continues and it is delayed. Even though it is delayed, the capacitor full charge will be discharged from it and it flow through the inductor. Now what happened? Capacitor, there is no charge, but electrostatic energy full is converted into magnetic field energy, because when we charge flows through the inductor, the magnetic flux linked with that it changes into a magnet. That and all we have studied. So magnetic field energy, now inductor is having magnetic field energy. And when all the charges are discharged, what happened? There is no current to flow through that, so flux linked with L decreases. Stops, actually, it stops. Flux linked with the L stops. There is no variation. So that it stops, and what happened? An EMF will be induced to oppose that decrease in flux. An EMF will be induced in the inductor to oppose the decrease in flux. So whether it is increase in flux or decrease in flux, an EMF will be induced in the inductor because of the property of self-induction. So when the flux linked with L decreases, then also an EMF will be induced, but that will be opposite direction as before. It will be opposite direction. So what happened when the flux linked with the inductor decreases? That EMF induced will oppose that decrease in flux and charge the capacitor again in the opposite direction. That is happening. Charge the capacitor in the opposite direction. Earlier, this plate was positive. And when all the charges found to this inductor, an EMF as the flux linked with L decreases, it will charge the capacitor in the opposite direction. That means this plate becomes negative and this plate becomes positive, because induced EMF will oppose that decrease in flux, like that. So positive and negative, here this becomes negative and this becomes positive, like that. Again, that induced EMF will charge the capacitor fully. Understand? Then that process is repeated. Then next case, what happened? This will, when it is fully charged, it begins to discharge. So electrostatic energy converted into magnetic field energy, magnetic field energy converts into electrostatic energy. Like that, the current begins to oscillate between L and C. Current is changing between L and C. That is LC oscillation. That is LC oscillation. It is a qualitative study only is needed. I need to study in detail according to the syllabus. Qualitative, you should know what is happening. Qualitative study is enough for that. You see, first the capacitor is charged fully, and then what happened? On removing the key K1 and putting in plug of the charged capacitor connected to L and starts discharging through L. An induced EMF is developed in the circuit, opposes the growth of current in L and hence delays it. When capacitor is completely discharged, energy stored in the capacitor appears in the form of magnetic field energy. As soon as the discharge of the capacitor is complete, current stops and magnetic field linked with L starts collapsing, decreases. Therefore, an induced EMF is developed which starts recharging the capacitor in the opposite direction. The recharging is also opposed and hence delayed. When capacitor is recharged completely, Then magnetic field energy is converted into electrostatic energy. The magnetic field energy reappears in the form of electric field energy between the plates of the capacitor. Then the entire process is repeated. This energy taken once from the cell and given to the capacitor keeps on oscillating between C and L. Capacitor, inductor, capacitor, like that energy is oscillating. So the natural frequency of oscillation, frequency equation, 1 by 2 pi root LC, frequency of oscillation, and nu equal to 1 by 2 pi root LC. Okay. Next is a transformer, a very important, just like AC, transformer is very important portion. What is a transformer? Let me ask. Have you seen that? I'll ask to Arunjit. Arunjit, have you seen transformer?
Yes, teacher, control.
Okay. What is the purpose?
Converter AC low voltage convert
yes. Step up and step down. Correct. AC voltage can be stepped up or stepped down. Nearby our places, it will be stepped down, because near to the power station, they step up the voltage to very high voltage, and near to our house and all, it will be reduced to 230 volts, like that, decreased. So transformer is an electrical device to convert alternating current of low voltage into high voltage or vice versa. High voltage in a low voltage akam, low voltage in a high voltage akam. Power house high voltage ആക്കിയിട്ടാണ് നമ്മൾ സെൻഡ് ചെയ്യുക. കാരണം പവർ ലോസ് കുറയ്ക്കാൻ വേണ്ടിയിട്ട് ഹൈ വോൾട്ടേജ് ആക്കിയിട്ട് സെൻഡ് ചെയ്യും. ഫാക്ടറിയിലേക്കൊക്കെ കൂടുതൽ വോൾട്ടേജ് വേണ്ടിയില്ല. അപ്പോൾ അവിടേക്ക് ആവശ്യമുള്ളതായിട്ട് സ്റ്റെപ്പ് ഡൗൺ ചെയ്യും. ഇനി നമ്മുടെ വീട്ടിലേക്കൊക്കെ അതിനേലും വളരെ കുറച്ച് മതി. ഇപ്പോൾ 230 ഒക്കെ മതി. അപ്പം അതിനനുസരിച്ച് സ്റ്റെപ്പ് ഡൗൺ ചെയ്യിച്ച് 230 ആക്കും. എന്നിട്ടാണ് നമ്മൾ ഡിസ്ട്രിബ്യൂഷൻ നടക്കുന്നത്. അപ്പോൾ അതിനെക്കുറിച്ചാണ് നമ്മൾ ഡീറ്റെയിൽ ആയിട്ട് പഠിക്കാൻ പോകുന്നത്. ട്രാൻസ്ഫോർമർ, ഓക്കെ, very important device, very useful device. In order to transfer power, for example, Idiki powerhouse, to our house, the power we are getting, power, electric power, which is produced in Idiki, that we are getting. So many steps are there in between that, in bringing that power generated in the powerhouse to our houses. So many steps are included in that. Okay, first it is stepped up. Then it is transferred to the lines, and then when it reaches to our nearby places, it will be stepped down. So step up transformer and step down transformer, both are required. So here, what is stepped up? Voltage. Low voltage into high voltage, or high voltage into low voltage. Okay, that is stepped up, increased or decreased. Principle, it works on the principle of mutual induction. When current is passed through one of the two inductively coupled coil, induced EMF will be developed in the other coil. You can see the figure. You can see the transformer here, a soft iron core. This is a soft iron core, this square type. So soft iron core, and over that you can see a primary coil. Primary coil is connected, and secondary coil also will be there. Secondary coil. If we want to step up the transformer, voltage we have to increase. So what we have to, here we give the input power. Input is given to the primary input, which is to be stepped up. For example, 230 നമുക്ക് 440 ആക്കണം എന്ന് വിചാരിക്കാം. അപ്പം 230 എന്നുള്ളത് ഇവിടെ കൊടുക്കണം. എന്നിട്ട് ഇവിടെ കൂടുതൽ നമ്പർ ഓഫ് ടേൺസ് വെക്കണം. നമ്പർ ഓഫ് ടേൺസ് ഇൻ ദ സെക്കൻഡറി മസ്റ്റ് ബി മോർ. അപ്പോൾ ഇറ്റ് വിൽ ബി സ്റ്റെപ്ഡ് അപ്പ്. Understand? So here, and voltage we can change. The number of turns will decide how much voltage is increased or decreased. Number of turns and number of turns in secondary. If suppose we want to step down number of turns in secondary, you have to reduce it, or it must be less than number of turns in primary. Step down, less number of turns. Step up, secondary number of turns more. So like that, we have to take the number of turns. So what all things we can see? Soft iron core and a primary coil, and there we give the input AC, which is to be only AC can be stepped up. The most important thing, DC we cannot step up or step down. Only AC can be stepped up or stepped down. Okay, so that is another advantage of AC current. That can the only AC can be stepped up and sent to different and all. DC you cannot be sent with the same voltage only. You cannot step up or step down DC. So here, step up transformer, number of turns in secondary is more than number of turns in primary. Step down transformer, number of turns in secondary is less than number of turns in primary. That is written here. A transformer consists of two coils of insulated copper wire. These wires are made up of copper, insulated copper wire. Insulated copper wire having different number of turns wound over a soft iron core. This is soft iron. Do you know why soft iron is used? Because whatever flux change is there, that will be linked with the secondary coil. So soft iron is there, flux linkage will be more. Maximum flux will be linked with the secondary. So but that is why we take soft iron core to wind these coils, copper wires. The coil in which electrical energy is supplied is called primary. Here we supply the electrical energy. And output is obtained across the secondary. ഇവിടെയാണ് നമുക്ക് ഔട്ട്പുട്ട് സ്റ്റെപ്പ് അപ്പ് ആയിട്ടുള്ള വോൾട്ടേജ് കിട്ടുക, അല്ലെങ്കിൽ സ്റ്റെപ്പ് ഡൗൺ ആയിട്ടുള്ള വോൾട്ടേജ് ഇവിടെയാണ് കിട്ടുക. Power which is to be stepped up is given in the primary. Output we obtain across the secondary. Of the secondary. In step-up transformer, number of turns in primary is less than number of turns in secondary. Stepped-up transformer. എവിടെയായിരിക്കും കൂടുതൽ? NS. NS-ലായിരിക്കും കൂടുതൽ. കുറവ് എവിടെയായിരിക്കും? NP. In step-down transformer, number of turns in secondary is less. Primary കൂടുതൽ. Then working. Then the alternating EMF is applied to the primary. Alternating EMF is applied to the primary. The flux linked with the secondary. So we know phi is directly proportional to I. When the alternating EMF, alternating EMF, varying EMF is applied. When that means current in that is varying, flux in that is varying. That varying flux will be linked with S. That's why alternating EMF is applied in the primary. So flux linked with that primary changes, and the flux linked with secondary also changes, because these coils are inductively coupled. But that is mutual induction. But whenever the flux linked with primary changes, the flux linked with secondary also changes. Here how the flux changes? Current is changing, alternating current is sent. So phi is directly proportional to I, phi equal to Li. And here in the secondary, phi equal to Mi, where M is the coefficient of mutual induction. So that we have learned. When alternating EMF is applied to the primary, the flux linked with the secondary changes, and then EMF is induced. Flux change according to Lenz's law, E equal to minus d phi by dt. EMF will be induced whenever the flux linked with the secondary changes, and EMF will be induced, and we get that EMF here. If number of turns is more, EMF is increased. That means voltage is increased. You can see the equations used for that. The flux linked with the primary, phi p is directly proportional to Np. Flux linked with secondary, phi s, directly proportional to Ns. Phi s by phi p equal to Ns by Np. And phi s equal to Ns by Np into phi p. and differentiating with respect to time, we get d phi s by dt equal to ns by np into d phi p by dt. What is d phi s by dt according to Lenz's rule? Minus of es. That's equal to ns by np into minus of ep. EP means EMF in the primary. ES means EMF in the secondary. So ES by EP equal to NS by NP. This is called transformation ratio. ES by EP equal to NS by NP is called transformation ratio. If I see NS is greater than 1, NS greater than 1, that will be step up transformer. NS by NP greater than 1, that will be step down transformer. If NS by NP is less than 1, that will be step down transformer. So that's why it is important, this relation, because that is the transformation, whether it is stepped up, whether it is stepped down, that is decided by this factor NS by NP. NS by NP greater than 1, stepped up. NS by NP less than 1, step down. Then for an ideal transformer, there is no loss of power. Hence its efficiency will be unity. But ideal transformer is very difficult to get, because in all transformers, different types of loss of power are there. Power is lost with different forms. So never we get 100% efficiency for a transformer. Efficiency equation is output power by input power. That is unity for which one? Ideal transformer. Ideal transformer, whatever input power is there, output also we get the same power. There is no loss. That is for ideal case only, but practically many losses are there. So ESIS by EPIP, power E into I power equation. ESIS by EPIP equal to 1. Hence, for a transformer, ES by EP equal to IP by IS. You cross multiply. ESIS equal to EPIP. Appa ES by EP എന്നുള്ളത് IP by IS ആണ് ഇവിടെ. For doing problems, study these equations. Hence, for transformer, we got a relation ES by EP equal to NS by NP equal to IP. Listen, this and all secondary comes in the numerator. Here, for current, primary IP. That is the numerator, IP by IS. Then different, I told you, in a transformer, there are many energy losses. Energy losses in transformer. The main reason for power loss, only 5 minutes more, so we can complete this video. Which are the different losses in the transfer? Energy is lost. We are not getting 100% efficiency. First loss is copper loss. Some energy is lost due to heating of copper wires used in primary and secondary, known as copper loss. So I told you now, on the soft iron core, copper wires are wounded. So copper is a metal. So what happens? Heating effect will be there. When current is passed through that wire, heating effect is there. Joule's heating effect, that is I squared RT is the heat energy produced. Resistance, anyway, we are even though we are using copper, it will have some resistance. So power loss is equal to energy loss is equal to I squared RT. And how can you minimize that? By using thick copper wires of low resistance. So how will you, what are the losses? How will you reduce it? Important question. Copper loss is reduced by taking thick wires of low resistance. Thick low resistance, inversely proportional to area cross sectional. Then iron loss. Eddy currents are produced in the soft iron core of the transformer. എങ്ങനെ eddy current reduce ചെയ്യുക? Laminating the soft iron core. ട്രാൻസ്ഫോർമറിൻ്റെ എപ്പോഴും laminated core ആണ് ഉപയോഗിക്കുന്നത്. Laminated, I told you while taking eddy current. That means instead of a thick copper soft iron core, it is cut into bread പോലെ cut ചെയ്ത് പറഞ്ഞില്ലേ, thin slices ആക്കി മാറ്റും. എന്നിട്ട് അതുമേലായിരിക്കും നമ്മൾ ഈ വയറൊക്കെ ചുറ്റുന്നത്. അപ്പോൾ എന്താവും? they will be insulated from each other. അപ്പോൾ എഡി കറണ്ട് ഒരെണ്ണത്തിൽ നിന്ന് മറ്റേക്ക് ട്രാൻസ്ഫർ ചെയ്യില്ല. അപ്പോൾ എഡി കറണ്ട് can be reduced. Laminating the soft iron core, that will minimize what? Eddy current. അപ്പോൾ eddy current loss we can minimize by laminating the soft iron core. ഇനി ഒരു ലോസ് ഉള്ളത് ഹിസ്റ്റീരിസിസ് ലോസ് ആണ്. ഹിസ്റ്റീരിസിസ് തവണ നിങ്ങൾക്ക് പഠിക്കാനില്ല, എന്നാലും പറഞ്ഞുതരാം. അതായത് ഇപ്പോൾ ഒരു ഇലക്ട്രോ മാഗ്നറ്റ് ഇപ്പോൾ ഇതിൽ നമ്മൾ കറണ്ട് പാസ് ചെയ്യുന്നുണ്ട് വയറിൽ, അപ്പോൾ അത് മാഗ്നറ്റായി മാറും. പിന്നെ അത് കറണ്ട് സ്റ്റോപ്പ് ചെയ്ത് കഴിയുമ്പോൾ അതിൻ്റെ മാഗ്നറ്റിക് പ്രോപ്പർട്ടി മാറിപ്പോവും, ഇല്ലാണ്ടാവും, അതൊരു അയൺ പീസ് മാത്രമായി പോകും. അപ്പോൾ അതുപോലെ മാഗ്നറ്റൈസ് ചെയ്യുക, ഡീമാഗ്നറ്റൈസ് ചെയ്യുക, വീണ്ടും മാഗ്നറ്റൈസ് ചെയ്യുന്നപ്പോഴാണ് കറണ്ട് പാസ് ചെയ്യുമ്പോൾ. ഒരു അയൺ പീസിൽ when we wind an iron nail, take an iron nail and wind it with insulated copper wire and send current. So what happens? Iron piece changes into a magnet. And stop sending current. Iron piece changes into iron piece itself. When current is sent through the wire which is wound over it, that changes into a magnet. When the current is stopped, again that changes into an iron nail itself. That is magnetization, demagnetization. And in that process, that core gets heated in that process. So here some energy is lost as heat energy. When the iron core undergoes a cycle of magnetization, the core gets heated due to hysteresis. അതിനാണ് ഹിസ്റ്റീരിസിസ് ലോസ് എന്ന് പറയുന്നത്. ദിസ് ക്യാൻ ബി മിനിമൈസ്ഡ് ബൈ യൂസിങ് കോർ ഹാവിങ് ലോ ഏരിയ ഹിസ്റ്റീരിസിസ് ലൂപ്പ്. അപ്പോൾ സോഫ്റ്റ് അയൺ ആണ് അതിന് ബെറ്റർ. So soft iron is used as the material in the transformer. Hysteresis loss will be less in that. Flux leakage loss. Flux leakage loss is produced by the primary Yes, whatever flux is produced in the primary may not link with the secondary. So some flux will pass to the surrounding also. Even though we are using soft iron, so that maximum flux will be linked with the secondary, some flux leakage anyway will happen to the air. That is flux leakage loss. The humming loss. The transformer, near to the transformer, you can hear some sound, humming noise. That means during the process of this, when we send AC to the primary and when the EMF is produced in the secondary, during that process, there will be change in its dimension of the core, lengthens and shortens like that. That process